Thank you guys, really happy to be here. As already introduced, my name is Ilya. I'm the technical product owner. Together with me I have Dominik Lekse, he's our cloud solution architect. And today it's all about one authentication gateway to authenticate them all, or how did we build a standard solution for managing authentication of traffic for applications on our platform. Agenda, as always. It's going to be very simple. We're going to first introduce ourselves, introduce the company we work for. We're going to talk about the different challenges that our company was facing. Then I will transition to Dominik, who will cover objectives, the solution, and also the learnings. So let's get it started. Who are we? We are Jochen Schweizer mydays Group. We are a company that you might have heard of. You can see our products in the different shops. We are operating in the voucher and the experience business. So if you ever are in a situation where you need to find a present for your friend or somebody who you like or for your beloved, check out mydays and Jochen Schweizer. So a bit of an advertisement there. What does it actually mean to be Jochen Schweizer mydays Group? So a Jochen Schweizer mydays Group is a company that contains several brands, each of which focuses on a specific business channel. mydays and Jochen Schweizer, you'll probably know. mydays is focused on more romantic experiences, where Jochen Schweizer is more extreme sports, adrenaline rush, and those are the type of the experience that you sell there. Regiondo focuses not on B2C, but rather on the B2B channels. The aim there is to help our business partners to manage their portfolios, manage their experiences. Now, all of those companies came together at the area of 2018, 2019, and when people come together, you have a lot of opportunities. You have a lot of benefits that come with it, but as well as that, there's one big problem that comes with it, and that's alignment. So as you can see here, this is something that we as a platform team had to actually deal with. You have four stakeholders. You have the Regiondo, which is B2B, Jochen Schweizer and mydays, which focus on B2C, and guess what? Jochen Schweizer mydays Group is a separate stakeholder who is actually focusing on internal solutions for which you also need services and infrastructure. You also have to take into the consideration that each of those brands and each of those stakeholders have their own services that they have developed over time. They're not a brand new startup. They are companies with a history, and you have to take that into the account. They have their own services and their own infrastructure. As a result, what that meant for us, we wanted to make all of those brands thrive. We wanted to reduce the complexity of all those brands. And what that meant for us and for all of the IT department, well, you have to promote reusability. Have services that everybody can use, that you can reuse as much as possible. Instead of introducing bicycles, wheels, or inventing new wheels, you just use whatever is there, and you make it accessible to everybody else. Same goes for platform. We all know we can use Kubernetes, we can use Docker, we can use anything you want, and you have many of it. You can always make a good example. But then the point is how to make it simple, how to make it less complex, and how to make it fast. And as a result, we wanted to have an identity and access management system as part of our platform, something very simple, something very usable, and something very straightforward for our developers to benefit from. And Dominik, well, take care.
Thank you. So Ilya and me, we are part of the platform team, and we are basically offering the different development teams infrastructure services, platform services, shared services, and in our setup, identity and access management is also built into the platform. And part of identity access management is selection of identity providers, for example, and also authentication. So you can deal with the authentication problem in many ways. We have basically the alternatives. So do we let all development teams solve their problem on their own, or do we as a platform team provide a standard solution as part of our platform? And we went for the standard solution as part of our platform. And in this talk, we want to also present how we did that, what were the challenges, and especially which components of the Ory stack helped to provide that. So when we want to, and I'm only talking about authentication as a service here basically, and when we want to centralize it, we want to have a component like, which we call authentication gateway. So what were the objectives of the authentication gateway? So the authentication gateway on our platform should abstract from different identity providers. And that means we wanted to avoid a scenario where we have like strong coupling between like 50 backend services, for example, and specific identity providers. When I'm talking about identity providers, I mean AWS Cognito, for example, for B2C actors, or Azure AD for employee users, but also social IDPs like Facebook or Google. Second, we wanted to establish a common internal identity representation in our services, so that basically these services, regardless of the IDP, of the external identity provider, through which the user authenticated in the first place, the identity to the services should look the same. And I'm going into more detail later on during the talk. Third, with the shared service, we wanted to reduce development effort for the backend service teams, because if we won't do that, we need to establish added value in the platform team, otherwise they could implement authentication on their own. Fourth, we wanted to reduce the service for implementation errors, and as you know from practice, they can happen easily, and especially when you, for example, during token verification, you can make tons of mistakes. All right, so after, and that was 2 years ago when we started this, after proof of concepts, and we've done proof of concepts with Ory Auth Keeper, but also several alternatives. Alternatives which we looked at were, for instance, Keycloak, Gatekeeper, but also more like complete solutions, API gateway solutions, not really comparable, but we also looked into them, were Ambassador or Kong. And I want to share here the outstanding reasons which made us decide for Ory Auth Keeper instead of the alternatives. Actually, and I thought of this like 10 minutes ago, the most outstanding reason was that Auth Keeper was actually a component which served exactly the features we needed. So not less and not more. Yeah. So compared to the huge solutions like Ambassador, they bring a lot of stuff which you don't need, and which we didn't need. So access rule concept was kind of nice for us, because we had the vision that in the offering we provide as a platform team, that the platform team operates the Auth Keeper deployment, and that developers of the different service teams are responsible for providing the access rules and defining the access rules. Yeah, so single Auth Keeper deployment supports multiple access rules, great. Then, as part of the single access rule, we could have these pipeline composition very flexibly in the configuration, without coding. So, when I talk handlers means authenticator handlers, authorizers, mutators. So that gave us the good feeling that we were able to implement requirements with Auth Keeper very flexibly. Third point is the extensibility. And what I mean by extensibility here is that, Auth Keeper comes with like built-in handlers. And as part of the proof of concept, we also looked into the implementation, because Auth Keeper is open source. And so we also added a new handler and said, well, that is quite easy. And we felt very comfortable that we would not run into limitations early. Fourth is the decision API, which is provided by Auth Keeper. And we wanted to avoid a scenario in which traffic, which needs to be authenticated, flows through our authentication gateway in a kind of reverse proxy mode. So as part of our architecture, we run on AWS as a base platform. EKS is part of that stack. We had at that time already an Istio as a service mesh, and Envoy as the ingress gateway. And Auth Keeper has proven to work nicely via the decision API, and Envoy to actually decide on whether to authenticate a request or not. Okay, so how does it look like from a 10,000-foot view? So at the very top we have our different actor groups. You would also put that in a threat model, I guess. So we have especially the retail customers accessing the shops, for example. We also have partner employees who manage activities or experiences. Sorry. And they all use different clients, like web-based applications, client-based web applications, the smartphone apps, and what we also needed to support is for these different actor groups, different identity providers. I mentioned them before. Azure AD for employees, Cognito user pool, for example, for B2C customers. And all of these different combinations of actors, clients, and identity providers require different or slightly different authentication flow. Auth Keeper helped us to really adapt, especially given with the access rule concept, to adapt to these variabilities. As part of our platform, we at the bottom here need to know that we distinguish between public-facing services. So the shops, for instance, are publicly facing, and also a public API, for example. And those public-facing services, they rely on internal platform services, which implement domain-specific functionality. And so two flows are important here. The authentication flow, which means an actor via a client obtains a token from an identity provider. This is what we indicate on the left side with the arrow. And then after an authentication flow, the tokens are used in authenticated requests to our public-facing services. And actually, before the request reach any of the public-facing services, they are authenticated via the Auth Keeper authentication gateway. So actually, takeaway here is that actually, as part of our platform, all inbound requests are handled by Auth Keeper. Okay, responsibilities of Auth Keeper, the most important ones. The most important one I already said in the architecture picture. So Auth Keeper performs for us the authentication decision for all inbound requests, because we implement zero trust. And second, Auth Keeper verifies external, that means from external identity providers, JWT access tokens, all relevant aspects, expiration, issuer, signature, etc. Third one is actually very important and, from my experience, forgotten in most, especially 5-minute tutorials. the rotation of the public signature keys of the trusted IDPs in a reliable way. So fourth point is that Auth Keeper issues an internal identity token, and the internal identity token is basically the implementation of the internal representation of an identity. So the internal identity token, the Auth Keeper is actually replacing the access token from which is presented by the clients, and replaces it with the internal identity token after a successful authentication decision, so that the internal services and also the public-facing services, so actually all services only see the internal identity token, and then can derive their whatever they know, user ID, etc. from that. This is an example of how such an internal identity token look like. And on the right side, this is the claims part of the JWT token. It's actually a signed token by Auth Keeper. So we see like a subject of the identity, and the store is basically like a short abbreviation of the identity provider, and this is what an internal service sees and needs to, and can use for doing whatever the service does. So we pass, most important takeaways, we pass this token in all transitive requests throughout the platform, and also because we strive for zero trust, this internal JWT token is also verified by actually all services. So that we don't trust even the request internal of our platform. Yeah? We verify that token in every service. I also want to talk about some customizations we have done as part of the implementation of Auth Keeper. And actually the handler architecture helped us to do that, because it is very easy to add new helpers, and this is what we have done. First example is we added a new authenticator which performs initiate and callback steps in an OIDC auth code flow. So if your application or if your service wants to authenticate a user using an identity provider using the auth code flow, the application is actually responsible to implement the initiate redirect to the identity provider, and also handle the callback from the identity provider. And this is what we have, like, again, we didn't want this to be implemented in all of the services individually, but we implemented in Auth Keeper as part of an authenticator, which could be added to an access rule and configured per service. So that helped us actually quite a lot. We use that authenticator with Hydra, with Azure AD. That works quite nicely. Second authenticator we added is an integration with AWS Cognitive User Pool API. And I'm not talking about the OIDC part of Cognitive User Pool, but the more, the non-standard part, the initiate auth based flow, which allows us to, in summary, do rich UX form-based authentication. And also here, Auth Keeper takes the responsibility of verifying credentials and establishing a session basically, and then using and then verifying request flows afterwards. We added a mutator for our internal identity token. That helped us quite a lot in standardizing the access rules, so that we do less mistakes creating the token, creating the claims of the token. We added to the existing JWT authenticator, I guess, yes, a token revocation check via Redis. And last addition I want to mention here is this is actually a very simple one, and for an access rule we allow matching any method, so kind of wildcard matching instead of like listing all HTTP methods explicitly in an access rule. So that helped us simplifying the configuration again. Yeah, we keep these changes in our private fork. So this talk is also a bit to like pique the interest of the community if they are like interests in these functionalities, or if you came to like similar problems. I think the first one is a good one for discussion. Maybe also the second one. Yeah, so I will be here after the talk to talk about. Last, I want to share some learnings, again, from 2 years operating Auth Keeper as part of our platform. I want to start with the good parts. So for us, Auth Keeper scales. Again, Auth Keeper authenticates every request which hits our platform. And we have not run into any issues with that service. Actually, we tweaked timeouts between Envoy and Auth Keeper in the beginning, but yeah, that's it. I guess there's also a benefit of this, like, because the component is really small and doesn't require much resources. Access rule standardization was kind of nice side effect. So it turns out that for like different combination of clients, actors, and identity providers, there are different standard access rules emerged, and they serve as a kind of template. So you don't have to reinvent access rules all the time, but you basically copy. Yeah? If you're a developer, you know, going to Stack Overflow, this is basically similar. You go to the existing rules, see which fit, and then copy. And again, because platform team is like, we are serving the internal developer teams. So we are happy if our developers are happy, and we experience no deviators. So all services rely on Auth Keeper for authentication, and we've managed to implement all authentication cases, requirements with Auth Keeper. So there are some hard parts still left, and those are the hard parts we are still working on it. So managing access rules. So this is what doesn't scale well currently for us. We started with access rules, or with like defining access rules in a YAML file in a config map, which is then released as part of the Auth Keeper Helm chart in our infrastructure. And yeah, this is how it's done today. And to give you some numbers, so that YAML file grew to 2,000 plus lines. And the vision is actually that we want really this clear responsibility distinction between platform and developers, that ultimately developers, so platform team would be responsible for managing Auth Keeper and securing operations, but developers should be able to very easily release new access rules. And our vision is that they basically configure access rules as part of their Helm charts, and doing access rule changes or releases of access rule changes as part of releases of their Helm chart. So this is the second part. We've seen that like Auth Keeper Maester as one solution to the problems. There have been some limitations. So I have another idea that why Auth Keeper may act as a Kubernetes controller to actually look for config maps or CRDs in the Kubernetes API directly. But yeah, we are working on it. Talking about working, we are also hiring. So if you like these problems and solve these problems, we run, as I said, on like modern infrastructure. Check out what's behind this QR code. All right. I leave the QR code. And now we can have questions.
We have time for one question.
So I'm considering scanning the QR code. No, just kidding. One question. Sorry. One question I have is for the caching. Do you use caching in Auth Keeper, or do you not use the caching system at all?
Which caching system are you referring internally in Auth Keeper? Or?
Yeah. For performance reasons, or is it like fast enough already?
For caching, so we use maps basically, maybe, yeah. So I remember some implementation where we added a map to map something faster, but there's no Redis behind. I think we cache tokens for a very, very limited time, so that they don't have to be signed all the time. But this time it's very limited. Yeah, it's like a careful trade-off you have to make, and for this purpose we use maps, I guess.
Okay. And does it have an impact on the RAM that you use in the system, or is it minimal?
RAM is cheap.
RAM is cheap.
Yeah. So
Okay. Thanks.
yeah.
All right. Thank you, Ilya. Thank you, Dominik, for sharing your experience.